All right, we have a question before us which says a waterfall is 120-meter high. Calculate the temperature difference of water between the top and the bottom of the waterfall, neglecting heat losses, given that acceleration to gravity g equals 10 meters per second squared and specific heat capacity of water 4.20 times 10 to the power 3 joules per kilogram per Kelvin. All right, let's briefly look at what a waterfall looks like. Now, if we have a place where water is being stored, or it can even be a natural place, a natural occurrence, where we have some volume of water stored up, such that the water is maintained at a particular height. Now, by the virtue of the height of the water will now possess what we know as what? Potential energy. So the water here, if this place is opened, such that the water falls. If the water falls out like this, from here to here, water rushes out. To rush it out like this, so upon falling like this, at this point, the water possesses potential energy, which is at this point. Now, upon water falling, the potential energy is converted completely to heat energy at this point. In that case, the temperature of the water is going to rise from, let's say, θ1 here to θ2 here. So, in tackling this question, we have to take our data. We have that the height of water H is equal to 1260, and the temperature difference θ is what we are looking for, and of course acceleration to gravity is g equals to 10 meters per second squared. Let's say the mass of the water is given as m, mass of water, and then the specific capacity of water C is given as 4.2 times 10 to the power minus, is 10 to the power 3 joules per kilogram per Kelvin. All right, so having established that potential energy at top is equals to heat energy at bottom. Potential energy, let's use it please. Potential energy is given by mass times acceleration to gravity g times height of the body, and heat energy is given by mass of the body, which is water in this case, times specific capacity of water C times change in temperature. So our mass of water is unknown, and since they occur on both sides, you can gladly cancel out, so that we have GH equals C theta. Now our G is 10 and our height is 1260 equals our C is 4.2 times 10 to the power 3, and our theta is unknown. So going forward, we're having 12600 equals, this is 42 in ordinary form, 4200 theta. So our theta will now be given by 12600 divided by 4200. Of course, this will cancel this, and then we are going to have 3 degrees Celsius. So in that case, there's going to be a rise in temperature of the water because energy can only be converted from one form to another. In this case, from potential energy here to heat. So the water is going to have a gain of temperature by plus 3 degrees Celsius. So if here is a theta, and this point is going to be what? Theta plus 3 degrees Celsius, which is the answer. All right, thank you.